Hello and welcome to the video lesson on optimization trick questions. Specifically, this one is a type of question that I call how many solutions optimize a given situation. So here there is a context like there would be in almost any optimization word problem. It says the owner of a dry cleaning service would like to maximize her profits. Different constraints limit the number of dresses and the number of suits that can be dry cleaned in a day. The polygon of constraints ABCD represents the different possibilities. The owner makes $4 profit on each dress and $8 profit on each suit. So in this problem, as opposed to one where you have to write out all of the inequalities and graph all of the inequalities and solve for the points of intersection, that first part of the problem has already been done here for you. So if you wanted to make a table to keep track of all the vertices and the profit at each one, you could just count out the coordinates, and in some problems they'll even tell you the coordinates. So if you want to practice and make sure that I counted mine out properly and you want to pause the video and give it a try, go for it. But otherwise, I'll just show you what I got as my coordinates for the vertices here, A, B, C, D. This is what I got. I got A 5, 13, B 13, 9, C 9 and 3, and D 3 and 5. And then the next step in a regular problem would be to plug each one of those vertices, each of those coordinates, into the profit equation, where here we make $4 profit on each dress, 4 times X, and $8 profit on each suit, 8 times Y. So if you wanted to try plugging those in just to make sure that I did it right or for practice, now's a good time to pause. I'll put up the answers. So I found that the profit at A was $124, and at B 124, and at C 42, and at D 46. So often a question will ask something like, what is the maximum profit? And if the question asks that here, the answer would be 124, because that's the maximum possible number that occurs. But what makes this a trick question is that some questions won't ask, what is the max profit? They could ask a question like, how many points optimize or maximize the profit, or which points maximize the profit. So I'll show you how we deal with that. And the way we deal with that is based on this theorem. It's that when two adjacent, that means touching vertices, have the same value in the objective rule, all the points between them have the same value too. So here we found that A and B have the same profit. Graphically, that means here A and here B, those two have the same profit. So if we circle back to this theorem, it says when two adjacent vertices, these are two vertices that are adjacent, one next to the other in the polygon, all the points between them have the same value. Everything along this line would have a profit of $124 as well. And specifically in this context, because we're talking about a number of dresses and a number of suits, X and Y in this problem have to be integers. They have to be whole numbers, because you can't dry clean half of a dress or half of a suit, or even if you tried to, you would still pay for the dry cleaning of one whole suit or one whole dress. So in this case, the fact that A and B have the same profit means that all the points between them do as well. And because we're only looking for whole number values, it means that there's this one and this one and this one as well. So the two types of trick questions that could come up could be, one, how many points maximize the profit in this situation? And the answer wouldn't be 2, even though in our table there are 2. The answer would actually be 5, because there are 5 different whole number points, all of which that have the same value. And that's 1. 2 could ask, what are the solutions? Which solutions maximize the profit? And if we were asked a question like that, I would say that point A represents 5 dresses and 13 suits. That's one answer. Point B represents 13 dresses and 9 suits. That's an answer. But these in-between points represent, you can count them out, 7 dresses and 12 suits, 8, 9 dresses and 11 suits, 10, 11 dresses and 10 suits, 12, 13, and 9. So you could also be asked what the solutions are, and if that's the case, you would have to list the amount of each thing. A question like this that asks how many or which solutions maximize or minimize is a very common trick question. So review the video and be sure that you are ready for a question like this.